Hello friends, welcome once again to another edition of My Teacher. In today's program of My Teacher, we'll talk about pH problem. What is pH? pH is a symbol for the degree of acidity or basicity of a solution. Solutions whose pH value is less than 7 are acidic in nature. Solutions which have a pH value of 7 are neutral, for instance pure distilled water. Solutions whose pH value is greater than 7 are basic in nature. Well, if we take 10 to the power of -8 hydrochloric acid aqueous solution whose pH value corresponds to 8, does it mean that the acid has been converted to a base? Can such a thing be possible? Well, in today's episode of My Teacher, Professor P.K. Sai Prakash will throw more light about this.
In this episode of My Teacher, I am going to share with you my classroom experience. Sometimes the students come out with very excellent questions in the class. One such question was on the problem of pH. The student asked me, "Sir, what is the pH of 10 to the power of -8m hydrochloric acid aqueous solution?" It was quite interesting because we were discussing about the chart of the pH, wherein I said 10 to the power of -1 molar concentration of hydrogen, which plus ions corresponds to pH 1, so on, and 10 to the power of -7 corresponds to neutral water, and beyond 10 to the power of -7 to 10 to the power of -14, the hydrogen ion corresponds to the basic solutions. In other words, pH less than 7, from 7 less than 7 to 0 is acidic solution, pH greater than 7 to 14 is basic solution. The question became interesting because when we take a 10 to the power of -8m hydrochloric acid aqueous solution, the pH corresponds to 8. That means the acid has been converted to a base. Is it possible? I said it's better we do an experiment and then check up. Later on we'll see how these results come out and we'll be able to explain them. So the experimental setup was very simple. We did it in two ways. Number one is with a pH paper. I've got a pH paper which in fact is a combination of different indicators, and above that is given the various colors, and all you have to do is to dip the pH paper in a given solution. I have with me a number of combinations of these solutions. So what I did was, I took hydrochloric acid, 1 molar solution as a stock solution. From that I prepared 0.1 molar hydrochloric acid, that is 10 to the power of -1 hydrochloric acid. From then on it is very simple. You go on diluting 10 times. Take 10 ml of this solution, make it up to 100 ml. So it becomes 10 to the power of -2. And take 10 ml of that solution, dilute it 10 times, it becomes 10 to the power of -3. In other words, m by 10 solution has become m by 100, m by 100 has become m by 1000. So instead of taking all sorts of combinations, I just have a set of beakers here with the hydrogen ion concentration 10 to the power of -1, 10 to the power of -2, 10 to the power of -4, 10 to the power of -6, 10 to the power of -8, the problem solution which the student asked. This can be done simply by diluting the stock solution 10 times and ultimately coming to this. The question was, is an acid going to become a base? Okay, just to check up, let's dip this indicator paper in this 10 to the power of -1 solution and check up the color. We shall be seeing this in close-up also, but when you compare these colors, you'll have this in the range 2 and above. So here the solution is 10 to the power of minus 1 of hydrochloric acid, H plus ion concentration. We go to the next one. Similarly, I have a solution 10 to the power minus 2 hydrogen ion concentration. Once again, I take a strip of this paper, dip it in this and compare it with this color. You see it matches exactly with the pH 2. So these are rough indications of the pH here. The next one, I'll go to pH paper, the next pH solution, 10 to the minus 4 hydrogen ion concentration, dip it and you see it matches with pH 4 roughly. Then come to the next solution, that is 10 to the minus 6 of hydrogen ion concentration, and you can check up that it matches with pH 6. Now the problem solution. Let's dip this pH paper in the hydrochloric acid concentration 10 to the power of minus 8 and check up. If it were to become a base, or if it were to be converted into a base, we would have got some of the darker colors here, but you see that the color is somewhere between 6 and 7. So an acid has not become a base. An acid is still an acid. But when you calculate based on simple calculations like pH is equal to minus logarithm of the hydrogen ion concentration. The hydrogen ion concentration being 10 to the power of minus 8, if you plainly substitute that value, you would end up with a result of pH is equal to 8, which is clearly in the basic region. But experimentally it is not so. In order to confirm this, I'll also do it with the help of a pH meter. So here is an experiment where I'm using a digital pH meter and I have the buffer solution. I'm using an electrode. First we standardize this pH meter using a buffer. I'll buffer of pH 4. You know that a buffer solution is one which maintains a constant pH. In this case it's pH 4 buffer. I switch on and get the value standardized as 4 for this standard buffer. Okay, I'll get back to the standard standby position now, and we shall now check up the pH of all these solutions. This is the standardization process, that is a calibration process for any experimental setup involving pH measurements. Now I'm going to wash this because we have already used it for a particular solution, and after washing this, shall dry it up and then take the next solution which we have corresponding to 10 to the power of minus 1 hydrochloric acid. We'll check up, bring it to this position. The pH comes out as nearly 1.1 or so. Remember that you are not going to get exactly 1.0 theoretical value. It's going to be somewhere near that region because the dissociation of HCl is not 100% complete. There could be ion pair formation, there could be incomplete dissociation. The value nearly 1 corresponds to pH 1, that is 10 to the power of minus 1 hydrochloric acid. A 10 times dilute solution is the next one. I once again repeat the process of washing it and determining the pH. Meanwhile, we'll get this instrument to the standby position. I'll wash this because it was previously used for a different solution. Once again, I try this and go to the next solution, which is 10 to the power of minus 2 H plus concentration. Switch on this and check up. The value comes out as 1.9 and it will be nearly 2. So 10 to the power of minus 2 H plus concentration corresponds to nearly the value of 2. We go to the next solution similarly, that is 10 to the power of minus 4. The process once again to be repeated. I have this in the standby position now. Let me switch on this and bring it to the pH position, and you get this nearly 4. You can see the close-up again and see the value nearly 4. So the next one is 10 to the power of minus 6 hydrogen ion concentration. Now the concentration of H plus is becoming less and less. So let's see what happens. We have the process of cleaning repeated over and over again, and now I'm dipping this in the solution labeled 10 to the power of minus 6 HCl. Let me check up. The value comes out as nearly 6. So 10 to the power of minus 6 HCl corresponds to pH 6. Now come to the problem solution. So we wash it more carefully this time, because this is the one which the problem we want to solve now. Experimentally, we would like to determine what this result is. Let me check up. The problem solution says diluting the hydrochloric acid to a concentration 10 to the power of minus 8 molar solution. So dip this inside, switch it on and see what the value is coming to. You see that the value is 6.93 or so. That is, it is not exceeding 7. The expected value was 8. Experimentally, we have seen both with the help of the indicator paper, the universal indicator paper, and this pH meter, that the value is not exceeding 7. That means acid is still remaining an acid. By dilution, you are not in a position to convert this acid into a base. That's quite an interesting result. Now here I have, just to show in the case of the indicator paper, what would happen if this were to be dipped in a base. Now if you have a base here and dip this, immediately you turn into a darker shade corresponding to pH 10 or 12. Now what has happened here is, we have the dilution of the hydrochloric acid to the extent of 10 to the power of minus 8. Under these circumstances, you have something else happening. Water, which also ionizes into H plus ions and the OH minus ions, and the concentration of hydrogen ions in water is 10 to the power of minus 7, which is 10 times greater than the concentration of the H plus due to the acid which has been diluted. Therefore, in the actual calculation of the hydrogen ion concentration total, we have to take the sum of the concentrations of the hydrogen ions due to the acid H plus diluted, that is 10 to the power of minus 8, plus the hydrogen ion concentration contribution due to water itself. When you add up these two, you will get the total hydrogen ion concentration as 11 into 10 to the power of minus 8 m molar solution, or in SI units it is mole per dm cube. Now the formula for pH determination is pH is equal to minus of logarithm of the hydrogen ion concentration. We have calculated the hydrogen ion concentration as 11 into 10 to the power of minus 8. When you take the logarithms on both the sides, log H plus is equal to logarithm of 11 into 10 to the power of minus 8, and take the minus log H plus value, which is equal to pH. The pH comes out as 6.96, which is less than 7. That is, the HCl acid is still an acid and not a base. So, these are the two simple experiments, very convincing to the students to show on dilution an acid cannot be changed into a base, though by simple calculation it would look the 10 to the power of minus 8 is in the basic region. Under these conditions of very, very dilute solutions of acids or bases, the contribution of the H plus or OH minus ions due to water cannot be neglected. We don't do the same thing when you take this H plus as 10 to the power of minus 2, because 10 to the power of minus 2 plus 10 to the power of minus 7, the value of 10 to the power of minus 7 is so less that it can just be neglected. Therefore we say 10 to the power of minus 2 H plus ion concentration corresponds to pH 2 theoretically, and experimentally you will get approximately 2.
So friends, sometimes even classroom teaching experiences can throw up challenges. Well, if you have come across any such similar situations, you are welcome to write to My Teacher, care of Audiovisual Research Center, Usmania University, Hyderabad, 5,07,000, or you can fax us at 040-701-8769. So till next time, bye.